Hello, welcome to another devlog for my 2D space game. Getting started on the compound shapes. I have this simple one, giving us two rockets merged together. Combine method. I was trying to do a lot more complicated stuff, or I thought it was more complicated than it was at first. So you can't change the bodies of a shape, but you have to remove that shape from the space first, and then you can just re-add it. So that's pretty nice. So we don't need all of these shenanigans. We can also now supply a body parameter to the shape init method, and that does the same thing. So compound shapes is simply we're just sharing the same physics body. But the next step is getting offsets working. So these polygons or rectangles, they use polygons under the hood. All the vertices need to have their positions offset to the desired amount. So by offsetting all the vertices for one of these rectangles, we can position it wherever we want relative to the other shapes in the compound shape. I got some offset implementation done for rectangles and for circles. I haven't tested this one yet, but circle has a built-in offset since it's a simpler shape. But for the rectangle, check this out. So now we're applying thrust here, right, to this part, and it rotates, which is great. It means it recalculates the center of gravity and like the moment and all that stuff for us automatically. So that's awesome. I love this engine. So that's pretty much perfect. Now I just want to make it more convenient to join shapes together, because I don't want to have to enter this manually. So I imagine like two shapes can be free, like if we don't join these, then we should be able to join these at any time. And then in the game, I'm imagining we're gonna have a welder module which can weld nearby shapes together if they are touching, is the idea. And that's gonna require power. And then I'm thinking a torch to be able to separate shapes. We're gonna need to implement a way to calculate the offset automatically and join these shapes at any point. Maybe with a keybind for now? So I'm thinking about what the user interface is gonna be to join these two shapes together. Like, are you gonna select both of these, like control clicking them, or like click and drag a box to them to select them, and then right click and like fuse or weld together? Or are you just gonna like right click one of them, click weld, and then click a different shape? That's kind of bulky. I don't know. To properly combine two shapes or like to weld them together, attaching two shapes to a compound shape, it seems we actually do need to recreate the shapes. So I'm getting the offset first relative to this body. That's one we keep. We get the offset to the shape we want to combine with. And then we duplicate that shape and we set that offset and we set the body. This is a nice duplicate method. It uses the same methods as our serialization, but it doesn't serialize. It keeps everything as Python objects. And then we delete the old shape and we return the new shape. And for our simple scene here, it seems to work fine. So initially I tried keeping the original shape and just attach it, but it seems we need to recreate all the vertices, which is why we just create a new instance. I added this little weld keybind. So when we press B, hopefully they're gonna combine. Let's see. So they're free to move around. And whoa. Okay, well, kind of worked. try that again. So the camera definitely needs some love. So I have this issue right here. I'm trying to connect these two shapes like this, but when I do, they teleport, and I'm not sure why. They move like that. I could reverse the order here, but then this becomes my point of reference, and the whole shape teleports to the left instead. Okay, I found the missing piece while I was jumping around when we were welding it. So right now they're not welded. I paused it because they're actually gravitationally going towards each other. If I play, you can see it. Pretty cool. So now there are two individual shapes. We have the position to the right and position to the left. And when we're merging these or welding them, I want to keep the shape and the body on the left. The shape is a rectangle and it has a physical body. And same with the right one. And then I'm gonna take the proportions and dimensions of the right one. We're gonna copy it, but we're gonna set its body to this body. So it creates a new one in place. And then the position of this one, we calculate the offset based on this position. And that's what we offset all its vertices with. But the missing piece is the position of this new shape. It tries to set it to where it is now. But the new body is over here. So when we combine it, all we have to do is set the position of the new shape to our own position, or like the single body we're gonna keep. And I'm playing it now and welding, and we have the perfectly smooth weld. Let's go. I wonder what happens if we save now. Wait, that actually works without any changes? I did not expect that. How is that possible? But yeah, now the issue is let's reset this, and then if this is at an angle, it doesn't follow the angles. So what I think I need to do, instead of only using the center position, uh, we need to look at each vertex compared to the body we're merging to. Oh, I just realized why the serialization works with compound shapes right off the bat. It's because I added body to the init parameter, and that's used automatically here. We get all the init parameters with this function. I'm trying to figure out how I want this to flow. It's really hard to wrap my head around. But this combine method, we want to duplicate the shape. But when we do that, we want to initialize it with different parameters. But it should be intuitive. Like I strive for all the code to be, right? I want to have as little programming debt as possible. But then there's always the balance, like you can't spend too much time perfecting it. Anyway, so I think I want to find the common denominator for the current two ways to create a shape. So what I'm trying to do now is implementing an alternative way to create the shape. And the common denominators, I believe, is on the vertex level. So maybe a rectangle or a poly should be initialized with vertices instead. Oh my god. Alright, I've got a structure I'm super happy with. I found the common denominator for the two ways we want to initialize a poly. I've changed this to poly now. A lot of changes being done here at once. I removed the static option because if we want a body to be static, we can just set that there instead. So much cleaner. Circle is still a mess. I'm just getting the rectangle or poly working. So now we have this one, init rectangle, which is like the old one, but we create the vertices with this base vertices method there, and then that's what we supply when we instantiate the class there with the vertices. But then we have this other one, compound. Same thing there, we get the vertices, but this time we to call init compound, we need view, body, and shape. View is needed for all of them. I've also cleaned that up. So before I I added duplicate methods to the view, but that's also gone. Now let me show you that quickly. It should be in here, shapes, and this thing. I used to have this, but it was so annoying because I was changing these all the time, and then I have to search and replace, and yeah, want to keep it minimalistic. But the downside is I have to update all my examples to this now. Before it looked like this. We did view dots, but now we do the shape class dot, and then we add view there instead. But I think that's much cleaner. I'll happily update all my scenarios here. So now I've updated the combine here to use init compound, get the class from that shape. So the idea is init compound here, I made this part of the base class, which is my shape, which not very clear there, which is overridden by each different shape, currently poly and circle and segment. Just like we have the draw and bounding radius functions that are different for all of these. So the init compound for polygons work like this. We get the vertex positions in the world from the shape. That's like the old shape that we're gonna replicate, but then attach to the new body. And we convert those world coordinates. You can look at that here. We convert these into local ones to the body, and those are the new vertices to initiate this one. Just like we use the base vertices to create an individual rectangle that's not a compound shape. So then we get those vertices there, and we also supply a different body. The body is optional there, as you see there. And if the body doesn't exist, we just create a new one. Oh, this is old code. I think I'll just go like this actually. If body else there, yeah, that should be good. Body if body else. Should probably do this. Oh God. Fat fingered when I'm trying to be fast for the camera. Alright. That's cleaner. Okay, awesome. And I haven't shown you yet. So let's load up the example. Right here. Oh God. Okay. What did I mess up now? Oh. Okay. So it has to be like this. There we go. So then our static property is probably incorrect as well. Body type. Boom. That's how we make a new body. So how do we check the body? Maybe there just is a type? Body type. There we go. Okay, so we go like self the body dot body type equals to, if it's an integer, that should do it. So let's try this again. Okay, so we have these shapes that are loose, and oh my God, it's so smooth. No hitch at all. Oh, that's perfect. All right, I'm getting the circle up to speed as well. Let's see if this works. Okay, got it drawing. We have an orbit, suborbit, whatever. Okay, let's try welding. Oh, dear God in heaven. All right, so what's wrong with the circle offset? Let's print the offset. That's a good start. Boop boop and boop. And what do we have? It looks good to me. Oh, it's my drawing, isn't it? Boom, boom, boom. Okay, let's try that. Oh, yeah. Nice. Wait, this still? Okay, so we're not keeping the angle of that one. But for the two rectangles, we get that for free because we calculate each vertex. I've introduced the concept of an offset angle for the circle, and that's used pretty deeply here in the angle. So we're checking if there's an offset angle, we just add that. And same for the position. If there's an offset position, we add that there using the angle of the body. So we calculate the offset position and angle here in the unit compound method. Pretty simple there. But adding this now, well, let me show you how it looks like first. So we have a rectangle and a circle. And go. And it's perfect. So nice to see now. Got the angle stayed. Before the angle reset was the issue. But having added these offsets to the circle, I feel like I should do the same to the poly or the rectangle. Because here I apply the offsets in the unit compound method, meaning that the return position for a rectangle in a compound shape is going to be incorrect, whereas the circle one is correct now because it listens to the offset. I feel like I should make that cohesive there, make it the same. Alright, I've reshuffled the code. Let's see if it works. It doesn't. Was it rotated? Let's try that. Okay, nice. That seems good. Let's reset it. Let's rotate this one and this one. That's perfect. So I moved the offsets to happen in the init method for poly as well, just as with circle. And I'm applying the offsets to the vertices here. And here in the init compound method, I now use the exact same vertices, but I only apply the offsets there, which are calculated in this method here now. That is called by two places now, for the circle and for the poly. So it's the first thing in both of the init compound methods. So this is super clean. I'm very happy with this. Let's try the circle. And the next step is like doing three shapes. Rotate, rotate, and perfect. Nice. Oh, and now when I click this circle, the camera should shift because it should return this position. Yeah, nice. And then thrusting here, I now expect it to rotate left, but it doesn't. So we can offset it right there. Interesting. What we're doing here in the thrust function, we're applying it locally to the body. But if we replace this 0, 0 with the offset position, which is just 0, 0 if it doesn't exist, I believe it should work. Let's try it. That's like before, perfect. And yes, slowly rotating to the left. Nice. I've updated the weld keybind, so now we should be able to weld with any shape where the body isn't the same as the active shape. All right, let's try this. So let's get this shape and then click it. Okay, we got the circle. Let's move this one up a bit. And now let's click it again. Oh yeah, very nice. But now the opposite is not gonna work. So now we're with the circle, but if we go with this one, we try to merge with this compound shape, I have no idea what's gonna happen. Okay, we stole it. I updated the combine method, so now we're iterating the compound shapes, and that's a new method as well. We're simply looking at all the shapes in the body, and then I've assigned the my shape object to each engine shape, so we connect those that way. So we get my classes and not the built-in ones. And then we're getting the class of the object, and we call that classes init compound method, and then we delete it. And that works really well. So everything is loose now, and I just welded with the sphere, and then go with this one now. This is by itself, and then weld, and everything's connected. And if I apply a thrust to this one, it's kind of balanced. Nice. So we can now combine compound shapes any way we want, I think. Really cool. That means we are now completed compound shapes. And next up for 0.2 is modules. Modules are things with functions, like the thruster is a module, and like a miner, or like a gyroscope to rotate and consume power, an antenna to communicate with, and then like being able to optionally limit the ratios for them and such. I think this is the next step.